All right, in this lecture, let's talk about what we're going to learn in the course. So the title of the course is the top 5 libraries for machine learning in Python. So we know we're going to learn about something called Python. What is Python? Python is a high-level programming language. So what's high level mean? When you hear the word high level in terms of programming languages, think human readable. It's more intuitive for you and I to, oh, I can't spell readable. It's easier for you and I to read. The low level down here, low level, means it's much closer to the machine. And it's much harder to work with and learn. So the course title also talks about libraries, right? So these things are our libraries. So what is a library? Each of these libraries is no more than groups of code. Groups of code, groups of code, groups of code. Each of these is simply code. And it is code that we can import into Python, right? And the code in here has functionality that extends the Python programming language. Pandas allows us to work with data, right? If we wanted to import pandas to clean our data and then scikit-learn to build a machine learning model, we could do that. We can mix and match these. It's not like we can use pandas here and then that's it. It negates the other ones. We can use these two if we want. We can use these two if we want. We can use NLTK by itself. NLTK is Natural Language Toolkit, and this is for text mining or for natural language processing. Right? So here we have 4. In the course, we're going to have 5, right? And there are many others. We could create a whole bunch of these, right? We could come here and draw another line. Oh, that line's horrendous. And we could say Keras is a library, right? Keras is a library for building artificial neural networks. We can import that into Python, right? So this ability with all these hundreds of libs, so with all these hundreds of libraries, Python has really become the standard for building applied predictive models. So in the course, we're going to learn how to use these models, right, to build machine learning projects. All right, in this lesson, let's talk a little bit about the terminology of machine learning. So what is machine learning? It's a type of artificial intelligence, right? That's the top level container that provides computers with the ability to learn without explicitly being programmed. And that's the key, explicitly being programmed, okay? If I have to write something to look for, let's say, the number 2, then that's not machine learning, right? Why? Because I wrote a statement to find that number, right? Machine learning looks at patterns. Here is a set of data. Here is a model. A model is a group of algorithms. I point this model at this data, and the model will eventually give us an output. Now, maybe the answer is 2, maybe it's not, maybe it's 3. However, I've done nothing here in the model to explicitly say, I'm looking for 2 or I'm looking for 3. It does the learning inside our model. All right. All right, let's continue talking about the basics of predictive modeling, which is what we're going to do. This is an Excel spreadsheet, and almost everything we do is going to be a CSV, which is a comma separated values document, which is essentially an Excel spreadsheet. Right? So in machine learning, these things, we call them columns. In machine learning, they are called attributes. This is an attribute. English education, number of children, total children, those are all attributes, right? Again, we call them columns, they call them attributes. We meaning I've come from the world of Excel or I've come from the world of relational databases. This is a row, right? If we were to take this the whole way across, we would say this is one row. Well, not in the machine learning world. They say this is one observation. All right. We call this thing an Excel spreadsheet. They call it a data set. Okay. Over here, we're trying to predict something. What are we trying to predict? With this data set, we are trying to predict whether a person is a bike buyer or not. Right? There's a column bike buyer. We're trying to predict whether they're going to buy a bike or not. Right? 1 means they're going to buy. 0 means they're not going to buy. I can't spell. Variable. That thing we are trying to predict in a supervised machine learning model is called the target variable. Right? Supervised simply means we have a data set. Well, how do we predict whether the person is going to buy a bike? We do that with, ooh, that's really a bad line, isn't it? All of the other, oh, that is bad. That's all right, you get the idea. Columns or attributes, remember they're called attributes, in our data set, right? And this is called training data. All right, so we only have a few, but these are really key terms that are going to help us throughout the course. All right, in this lesson, let's learn about the machine learning process. All right, there's a process, and this is it. Before we get started, we have to talk about two things. Number 1 and number 2. And these are the different types of machine learning. One is called unsupervised. We'll call it unsuper, and we'll call it supervised. The goal of unsupervised learning is to model the underlying structure in order to learn more about the data, right? So in this, there is no data set, no DS, right? This is not that common. Supervised learning is where we have a data set, and it's usually a CSV file, and we point our algorithms towards the data set, right? This is 99% of all applied machine learning. Applied machine learning is someone hires you, you work in the real world, you build models, you implement those models, and people consume those models, right? So in the supervised learning machine world, we need data, and it's going to be raw data. And what's raw data mean? If you're lucky enough, it's going to be in a relational database or an Excel spreadsheet where you can easily clean it. Now, that's not what's going to happen most of the time. Most of the time, it's going to be yucky. It's going to be unstructured data, and you're going to have to structure it. And this is part of the process that no one really likes. This is cleaning the data. All right, so we've got our data, and then we have to clean it. And this cleansing part really accounts for about 80% of our workday. Building the model accounts for only a small part of what we're going to do. This is the big one. we're going to spend a lot of time cleansing our data because data in the real world is dirty. Now, a lot of the tutorials you'll do, including all of mine, are cleaned CSV files, right? The data is given to you in a CSV file, and all you have to do is build a model against it. And that's a lot of fun, but that's not what happens in the real world. So our next step accounts for about 10%. And this is actually building the model. This is the fun part. This is where we decide which algorithm to use, and this is where we use Python. We've got our Python, and we're building models, and we're looking at the results. And after we build the model, we need to make a prediction. Well, we don't. The model does. The model's going to make a prediction. So it's really a four-step process. We've got to get our data somewhere, right? We've got to cleanse it. This is not the fun part, but the part that's going to take most of the time. We're going to build our models. This is the fun part. And then there's going to be an output. And then we're going to look at different metrics to see if the output is what we want. If not, then we have to go back to the model building process and start over. All right? So it's an iterative process after the data is cleaned. And you just create this circular process until you're happy with your model. What happens when you're happy with your model? You exit the loop and go ahead, put it in production. And that means you allow someone to consume your model. That means they're going to take some data here and they're going to put X and Y in here, and then they're going to get results. And based on your model, they're going to act on those results, right? And these results could be anything, right? That is the predictive modeling process in Python and actually in any supervised machine learning project. All right, in this lesson, let's go ahead and install Python. Now, when we install Python, we have two options. We have an older 2x version and we have a 3x version. Most of the time, especially if you're in the Windows world, you want to go with the newest. However, in the applied machine learning world, Python 2x is still used heavily. So oftentimes I'll install 2x. For this video series on NLP, we're going to go with 3x. We go to a search engine and we type in Python and we type in Anaconda and we hit enter. And the first one should be where we want to go. Download Anaconda. Well, let's go look and see if this is the right page. This is it. Anaconda from Continuum Analytics has bundled both versions for us. Here's the 4.3.1. Let's see. The 3.6 version and the 2.7. We want to go for this series with the 3.6 version. So let's go ahead and install that. No thanks. Appreciate it though. All right, we finished downloading. It took about 2 minutes. Let's show in folder. Go on folder. Let's show in folder again. All right, for whatever reason, that's not behaving. All right. Oh, here we go. I clicked on it to run and it says let's run it. All right, well, go ahead, let's run it. Sure. This is really slow and this is a fast laptop, so this is really strange. All right, here we go. Anaconda, yep, thank you. Next. I agree. Nope, every user's me. Sure. Yep, that looks great. Yep. All right, so we've got it completed. That took a few minutes. All right, let's go ahead and open. Let's type in Anna for Anaconda prompt. Anaconda. There's the Anaconda prompt right there. Let's hit enter. Let's pull this to the middle. Jupiter. Nope. Let's open a Jupyter Notebook by typing in Jupyter Notebook, and there we go. New Python 3 notebook. All right, so we're not done. We've installed it successfully. Now I need to go install NLTK. All right, now we need to install NLTK everything. Now, what's everything? Well, there's this kind of fork. You've got the data, and you also have the modules. We want both, and this will do it. So when you download the items for the course, this will be a Jupyter Notebook you simply place into the default directory, load it, and here we go. So in order to do it, we're going to copy this, Control C. We're going to open our Anaconda prompt. To do that, we go into our search, type Anaconda, hit enter. Our Anaconda prompt will load, and then paint. There we go. We'll hit Control V on the keyboard if you are a Windows user, and then we'll hit enter, and it will begin installing everything. And there we go. And it will get to this one point where it says, let's see, give it a second. There. This is going to take a while. I downloaded it. We have a really fast pipe at work, so I downloaded it at work, and it eventually does work, but it takes a little time. Once this is finished downloading, we'll get the prompt, and we'll be done, and we'll be ready to start tokenizing our data.
All right, in this lesson, let's learn about the Jupyter Notebook. The Jupyter Notebook is our IDE. An IDE is an integrated development environment. It's where we're going to write our code. How do we get there? For Windows, let's come over here and type in CMD and hit enter. And let's type in Jupyter Notebook. And hit enter again. And now we're going to get the home page. See, it says home, and it's a URL. And in order to open up a clean notebook, we come here and we come here, we navigate to Python 2, and we hit OK. And this is a cell, and this is our Jupyter Notebook. So the first thing we want to do is let's name it. So we just click on that. Actually double click. It brings up this dialog box, and we'll call this our first, I was going to say Python notebook. We'll say OK. And now we can see it's changed the name to our first Jupyter Notebook, right? So this is a cell, and this is where we type our code. A nice thing about this is we can also document what we're doing. So notice here it says code. If we change this to Markdown, and we come down here, and let's type in, how about a pound sign to make it a nice large header? Then we'll say, let's get started. Let's get started. And every time we want to execute a cell, we hit the control button and the enter button. And now that's run successfully. All right, now if we want to come up here and run some code, we go to the next cell. This adds a cell. And when we're highlighted here, we don't want the cell, we just delete it. We cut it. The scissors gets rid of it. Right? Let's write some code. Let's import pandas. Pandas is a library as PD. We're going to import pandas. We're going to alias it here as PD. So all you have to type in as PD to be able to use Panda. Control again, enter. It's running. You can see the little asterisks, and now it's finished. You can also run your code up here. Let's put that there and hit the enter. And it will execute and move to the next line. We can move our cells up and down. All right, so let's put our highlight there, and let's move the cell down, or move it up in that case. Let's move it down, and now we can type something else in here. Let's type in some more documentation. The import means the word import means to bring in to Python, to bring in a library into Python. All right, shift enter, And there we go. All right, so what are some other things we can do if we wanted to stop? We're executing some code and it's taking longer than we anticipated. We can come up here and hit the stop button, right? We can insert. If we didn't want to add, we can highlight our cell, right, and insert above or below, right? Let's come up here and type something. Let's say backspace 1 plus 1 plus 2, 1 plus 2, and we hit Shift Enter, and it gives us the output. Now, let's say we've done this the whole way down. We've got a big long list of code, and we want to clear the output. So let's come up here to Cell, Current Cells, Clear. Current Output, Clear. And that will clear all of our cells. And I promise you'll use that later. That's really a handy feature. All right, we can save anytime you want. This is kind of like forcing a save. It will auto-save every few seconds as you're working through the code. But again, you can force a save anytime you like. All right. Let's move back to the home page for a second. We have what we can see on our home page what notebook is running, or notebooks. So let's come down here and we can see our first Jupyter notebook is running. So we can highlight on this, right? Click on it, and we can come up here and we can shut it down, turn it completely off, and we could delete it. So let's go ahead and shut it down. Let's go ahead and open it back up. And it'll open up from scratch. Let's say we did this. Let's go Control Enter. This is how you're going to execute if you don't want to continue to hit this all the time. Most people will hit Control Enter. So let's go ahead and Control Enter. And there's 3. So this looks like it's run. And if we were to shut it down, right, it may save this for us. However, if we have a whole bunch of code and we start this again, each cell will have to be run, right? Once we close this window, right, this is our Python server. We close this, it shuts everything down, right? If we come up here and we see this, just like this, it's not been run, it's not been executed. You're going to have to step through the entire process again, right? Or you can run all the cells up here if you like, right? All right, so let's recap. So these are cells, right? In cells, we can type text. We have to come up here and say markdown in order to type some text in here, right? This cell, we have code, and it says code, so we can type some code in there. We can hit Control Enter to execute. We can also hit this little button here to execute, and that'll take you to the next line, right? If we want to come up and cut a cell, we use the scissors to cut a cell. We can easily add a cell by hitting the Add Cell. And if we want to save our entire workspace and we want to force the save, it's called a checkpoint, we hit the Save button, right? If we want to clear our screen, we come up to Cell and Current Cells, and we clear all the cells, right? As we go through, I will show you some more hints to work with our notebook, but that really is about it. That's all we need to know to get started building our model.
All right, in this lesson, let me show you where to install the notebook. So the downloads for the course are under the introduction here. It says course downloads. So we're going to go to course downloads and you're going to download the zip file, and inside the zip file is going to be a Jupyter notebook. And you're going to open that notebook and you're going to copy it to the location where you installed Python. And for most of us, that's going to be users, at least for Windows. Everything I do is Windows. Apologies to the Mac people. And under that we have MWest, and here they are. You can see these are IPython notebook files, and it's going to be this one. All right. So you're going to grab it, and you're simply going to grab it from what will be a zip file, and you're going to come to the directory, and you're simply going to paste it. So when you do that and restart your Jupyter notebook, you will come to home and you will see it right there. And when you open it, this is what it'll look like. It will be annotated for you. All right. Some of it will be more annotated than others. However, I did leave the code uncommented so that you can go ahead and comment it as you work through the problems. All right, in this lesson, let's start learning about pandas and let's write some code. So the first thing we need to do is open up our Jupyter Notebook. And to do that, we come down here and we type CMD, and then we find the command window, we hit enter, and then we type Jupyter Notebook. And then we hit enter, and in a second, it'll open up a Jupyter Notebook. And it opened it up on another screen, so I'm going to have to drag it over to this screen. Here we go. So this is our home page, right? So in order to open up a new Jupyter Notebook, we come over here to New, and we come down to Python 3. All the code in this course should work with either version. Let's go ahead and hit Python 3 to open up. All right, so here we've got our cell. And here we have code, and then here we have Markdown. Markdown is like HTML. So let's type in, thanks for taking my class, period. And now to run that, hold down your control button, this is on Windows, and hit enter. Markdown, HTML. Now let's add another cell. That's what these are called. These are called cells. And let's write some code. Well, let's write a comment. All right, so what's a comment? A comment is a line that isn't seen by the compiler. And the pound sign in Python is how we write a comment. This is a comment. Let's bring in pandas. Bring in means to import. So let's import pandas. We could do it like that if we wanted to. We could hit Control Enter. You can see the little asterisks over there. You could for a second. And when the asterisk is done, the code in the cell has processed whatever you asked it to. We want an alias. So let's go as PD. We don't want to have to type pandas every time we want to use it because we're going to use it a lot. Control Enter. And now we've just added the alias to our code. Now, if we wanted to, we could come up here and hit that button. It will execute what's in the cell and then move on. So we don't have to come up here and add a cell every time. It's up to you. Let's create a series. Let's create a series. What's a series, Mike? A series is a one-dimensional array-like object. We're going to call it S for series. How very original of us. S, PD. All right, so look, there's our alias. All right, PD. PD what? PD dot series. We need some parentheses and we need some brackets. And in here we're going to create a series with just numbers. Let's go 3. How about 5? How about 5 again? And how about 9? Let's go and hit Control Enter. All right, well, nothing happened. Well, it created the series for us, but we didn't ask it to write anything back to the screen. Right? So let's go ahead and do that. Let's go ahead and hit Enter and type S. Now it printed S, which is what? This. So it printed 3, 5, 5, and 9. All right. This down here is our data type. All right. It's an int or integer 64. We're going to ignore that now. So pandas is all about working with data. All right. So let's go ahead and manipulate the data. Let's go ahead and add this cell. Right. Click to add a cell. Let's go ahead and look at the top rows. So when we do this, do we have 1, 2, 3? Let's go ahead and add. I need another one. 6. We'll hit Control Enter. I need 5 entries. 1, 2, 3, 4, 5. All right, so I want to return the top 5 rows in that series. Well, how do we do that? We type in s.head. Pretty simple. And it returns the top series. Now let me show you something. What if I type in capital S.head? All right, name S is not defined. Well, what do you mean? We defined it here. Nope, that's a lowercase s. Python is case sensitive. Let's come back and put it back to where we had it. Control Enter to run the cell, and now we're good to go. All right, that concludes our first lesson on pandas and getting our hands dirty with writing some basic Python and using pandas to manipulate some data. In the next lecture, we're going to bring in some real data, not some that we created. All right, in this lesson, let's continue working with pandas and let's work with some tabular data, i.e. a spreadsheet. So let's come here and add another cell and let's import pandas. Import pandas as PD. Let's go ahead and control enter that to execute it. Let's put this in another cell. And now let's pull our data in from a URL, UFO data equals pd.read, right? UFO is simply a variable. I'm going to read the table. I need some parentheses. I need some quotes. I need HTTP, bit.ly, bit.ly, and UFO reports. And it is a comma separated file. So comma, and then we need space, sep, that's the separator, equals what? Equals, well, we just said, comma. So now let's import that. Great. You know, well, and imported it, but we didn't do anything with it. Well, yeah, we have to read it, all right? So let's go ahead and read the first few rows. Actually, the first 5 is the default by going UFO dot head, right? Boom, boom. Now control enter. All right, there are the first 5 rows. When I first saw this, I'm thinking 4. What happened? Well, remember, 0 counts. All right, let's move on. These are UFO sightings, by the way. Let's go ahead and read the state. UFO dot, no, actually, UFO, open quotes, and then single quotes, state. All right. Now remember, we've got state. What if I do this? Is it the same word? No. Remember, case is important. Let's go ahead and read the state. Now it reads all of our states in the first few rows. We'll do the first 30. All right, in the last 30, it looks like it. Let's add another row. Now let's come down and concatenate UFO, open quotes, location. And what's the location going to be? The location is going to be a combination of the city and state. So we need equals, so we're going to create another column here with the city and state in it. Equals what? UFO.city, city plus simple concatenation plus single quote, comma, that'll do, plus UFO.state, and now we want UFO.head to see if it worked. What did I do wrong? Ah, look what I did wrong. Is city capitalized also? Ha ha ha. All right, so after I just got finished warning you about the importance of case, I typed 2 lowercase letters and get an error and can't seem to fix it. So now we have, right, Ithaca, New York. So that's a space. Let's add another. There we go. A lot more legible. Let's go plus. Let's go ahead and look at the shape of our data. What's shape mean? It means the number of columns and the number of rows. FO, UFO, dot shape, control enter. Remember, each cell we hit control enter. When there, control enter to get our results. So we have 6 columns. Do we? 1, 2, 3, 4, 5, 6. We do. And we have that many rows that I'm not going to count. I'm going to take Python's word for it. Right? So let's look at the data types of those. So let's add another cell. What data types are each of those columns? Probably the same thing. UFO.d types equals control enter. And they are all objects. All right, let's go take a look at the columns. UFO.columns. Control enter. All right, so we've got our columns. All right, in this lesson, we've seen how easy it is to import some data and then to manipulate that data with some of the commands we've seen in the previous lesson and some new commands. All right, in this lesson, let's continue manipulating our data. So we've got our bit.ly here, and we've got our data, our UFO data. Let's go ahead and add another cell. And in the cell, let's remove a column. That colors reported column doesn't have a lot in it, right? So let's go ahead and get rid of it. UFO.drop, and we need some parentheses, and we need some quotes, and we need colors reported. Now let's make sure that I have the right case, comma, axis is equal to 1, in place is equal to true, no, equal, true. Let's go ahead and read it when we're done. UFO.head. And with that, we dropped that column that didn't have any values in it for the data we were looking at. All right, let's go ahead and drop more than one column. So let's add a cell. Let's come down here. Let's copy this. We'll use this as our base. Control V. Let's put some brackets. There is an open brace. Let's come over here to close brace. Axis 1, yes, in place true. Colors reported. Can't be colors reported because it's already gone. How about state? Watching our case. Over here, comma, quotes. How about time, because it's easy to type. So state, time, axis 1, that should do it. And now, we've just dropped those 2 columns. We're getting kind of light here in the columns, aren't we? Let's do some sorting with our data. Let's bring back, let's go up here, control copy, control V, control enter. There we go. Let's get back our data. Let's go new cell. There's our new cell. Let's go ahead and do some sorting. So we want to sort UFO dot. Let's sort on what? State. That's what we'll sort on. State dot sort underscore values. How about ascending is equal to false. FALSE. Dot. No, I said dot. Head. So we've sorted our state descending, right? Because we said ascending false, right? And the head gave us the first 5, right? Well, what if we want the first 25? All right, well, we just put 25 in there and hit enter. And now we've got the first 25, right? Again, and descending, because we've set ascending to false. Let's clear our cells. Cells, output, clear. Let's add a cell. Thank you. Now let's go ahead and sort UFO. Type the same way. Let's sort values, underscore values, and we'll put some parentheses, and let's get our data back. I want to be able to see what I'm doing. All right, thank you. And we're going to sort by city. C-I-T-Y. Dot head. And we'll hit enter. So we've sorted by city, right? All right, let's add one final sort. And this time we're going to sort by two values. So UFO dot sort underscore values, quotes, brackets, and the first thing we want to sort on is city. So we'll put single quotes, city will come out, we'll put a comma, and then the next thing we want to sort on is state. State. So we're going to sort on city first, and then we're going to sort on state, right? And then we'll do dot head, and we'll look at the first 25. Come to the end, hit Control Enter. And we've indeed sorted on city first, and then sorted on state. Here's a learning tip to see if you know exactly what these do. So I am going to uncomment all of the code. Right? This is all uncommented. This has some comments in it. So when you run through them, Control Enter. All right, what's it do? All right. Now you comment the code to see if you know what it's doing. So place the pound sign. So what is it doing? We are creating a variable called UFO. Then what? Pound sign. Then we are reading data into that variable from a URL space. All right, so walk through and comment these. Control Enter. All right, so with head, what's head do? Head returns, comment, pound sign. Head returns the top 5 rows unless you put something inside the function, and then it'll do the top 10 rows, right? So I'll have all these uncommented, and you walk through and add comments to these as a way of testing yourself to see if you know what these really do. That's a trick that helped me a lot when I first got it started. I would go through and uncomment someone else's Jupyter notebook, and then I would run the code and see if I understood what it did. And if I didn't, then I'd go Google it. All right, so this is a good way to see if you understand exactly what's going on when we execute the code. All right, in this lesson, let's learn about the array. Now the array, regardless of language, seems to trip people up a lot. And it's really quite simple. An array is a collection of elements of the same data type. Right? That's what it is in most languages, and that's what it is in Python. Now, the same data type just means here we've got a number 3. Here we have a number 5. We can't have a 3 and a string, a mic, and then a 0. No, you can't have that. It has to be of the same data type. Here, these are numbers. So this is an array of numbers. Right? This thing is called a one-dimensional array. I'll call one dim. All right, for one-dimensional array. All right, so this is 0, and this is 1. This is axis. All right, more than one of these is axes. Right? So how do we know the position of these individual elements in an array? Well, over here, if this is 0, then this must be 0. And in this axis, since we know the first element in any array is a 0, then this must be 0. So that means this must be 0, 0. All right, well, this is 0 because there's only one element, right, on this axis. So this is 1, 2, and 3. So this must be 0, 1. This must be 0, 2, and this must be 0, comma 3. All right. All right, in this slide, we have a 2-dim. It's a two-dimensional array. We've got an extra dimension here. All right, so 0 is the first position in our array here, 0 here. So this makes this position, this number 3, 0, 0. Over here we have a 1, a 2, and a 3. So again, a 0, 1. Now down here we have a 1. So what is this 5? This 5 is a 1 first, comma, 0. Right? So if we had another cell here, right, it would be 1, 1. All right. This is a simple two-dimensional array. Again, this can't be Mike. No, nope. Why? Because it's of the same data type, right, in Python and in most languages. So now we have, right, instead of a 2D space, we have a 3D space. So before we had this, right, we had this going down. Remember, we had the space, and this was, what was it, 0 and 0, right? Now we have another direction, 0 on all three parts of this cube, right? This is a multi-dimensional array. Obviously a little more complicated, right? But it's the same thing. It's the same idea, right? This is an axis, right? 1, actually 0. This is 1, and this is 2, right? For the different parts out in space, right? So don't make it any harder than it is. So anytime you get a question, what is an array? It's a collection of elements of the same data type. That's it. Doesn't matter what kind of array it is. Doesn't matter what dimension it is. That's the definition of an array. And it's fundamental to everything we're going to do going forward. All right, in this lesson, let's learn about creating some arrays in Python. And since we're talking about NumPy, let's go ahead and import NumPy. Let's create a comment. Let's import NumPy first. Import, just like we do with pandas, import NumPy as NP, right? Let's go ahead and hit Control Enter to run the cell. Let's go ahead and add another cell. Let's go ahead and create a simple array, a one-dimensional array, like we've seen in the previous lesson. Let's go X is equal to NP, you see we're using the alias, dot array, open brackets, all right, parentheses first, come on now, parentheses first, brackets, and let's add some elements to our array. How about 1, 4, 6, 7, 8. Now let's hit Control Enter, and again we've got to spell. There is no array. All right, there is an array, A-R-R-A-Y. All right, so we just executed our cell, but we haven't returned it. That's right. Remember, let's hit Enter, X. Now let's take a look at the array. And there is our array, right? Let's inspect our array, right? Let's do some things to the array. Let's add a cell, and let's go type. Speaking of typing, I can't type tonight. Type X. What type of array do we have? We have a NumPy array. All right, that's great. Let's add another cell. What is the dimension? 1 and dim. We just talked about the different dimensions of an array in the previous video. So is this really a one-dimensional array? Control Enter. It is a one-dimensional array. Let's go ahead and add another cell. So we have the dimension of our array. What is the shape of our array? X dot shape. Control Enter. And we have 5 elements in our array. You're like, well, wait a minute. Why is there nothing? There's just a 5 and a nothing. Well, because it's a one-dimensional array. What's the size of the array? Point. Hopefully it'll be the same thing. X dot size. Control Enter. All right, the size is 5. Right, 5 elements in our array. Let's do one more thing to it. All right, let's find the data type of our array. X dot dt. Control Enter. All right, so it's an int 32 or an integer 32. Right, that's the data type of the array. So in this brief lesson, we got to import NumPy. We defined an array. We defined the elements of an array. And then we inspected our array. All right, in this lesson, let's continue to learn how to manipulate our arrays and to learn more about our arrays in NumPy. Let's go and import it again, because I've got a clean slate here. Import NumPy as MP. Let's create our container. That's what the X is. It's simply a variable, a holder for our array. Dot. Let's see if I can spell it correctly this time. Brackets, and then 1, 2, 3, 4, 5, 6. And now let's print it. Come on, enter, X, Control Enter. There is our array. Let's add another cell, and let's get this first attribute of our array. Well, how do we do that? Well, X, then we have some brackets, and then what is the first element? And remember back to our lesson where we talked about the one-dimensional array, and the first element in that dimension was 0, so it's going to be a 0, comma, and then we're going to hit enter, and hopefully we'll get a 1. And that is the first element in our array. Well, let's go see if we can find the 6th. Well, it's the same thing, right? Control C, Control V. Let's go ahead and get the 6th element in our array. What do we do? 1, 2, 3, 4, 5, 6. Remember, this is not 1, this is 0. So this is the 5th element in our array, because 0 we just shown is the first. All right, let's go ahead and add another one. Let's move you up. We can do that by doing that. That's good. So let's get every element up until, how about the 4? Let's get these. All right, again, simple to do. X brackets, and this time we've got a colon, and up until I said the 4, didn't I? Hit 4. This should give us everything in the array up until. All right, let's go ahead and save our array to disk, something we won't do often, but we should learn how to do it. So let's go mp.save. I need some parentheses, quotes, X, comma, X. Now a question might be, Control Enter, where does it save it? Well, it saves it to the default directory, and my default directory is users in West. So if we go to date modified, so I have a lot of stuff in there, huh? There is X. That's the file we just saved. All right, and it's MPY. Why? Well, because it's a NumPy array. Well, how do we bring that back? How do we access that after we've saved it? All right, well, we load it. So let's go mp.load, parentheses. What do we call that thing? Wasn't it x.mpy? I think so. See if this works. Yep. So now we've just loaded that into our session here from disk. All right. All right, in this lesson, let's talk about scikit-learn. This is by far the most popular library in all of Python, and it is because it's the fun part. It is fun building models. Model building. It's not really real world, but whatever. So what is scikit-learn? Here is the best definition I could find. It's a library focused on model building. Yes, I'm a big fan of Occam's razor. So that's what it is. It has lots of libraries that we're going to import to build models, right? It is not focused on loading, manipulating, or summarizing data, right? We have our friends NumPy and Pandas over here for that, right? So let's talk about this process. So here we have Python, and this is the core language. And we have all these things on the periphery, all these libraries that we can import. Here's Pandas. We import it. We use the word import, as we've already seen, to import the functionality into Python so we can use the code that's in Pandas to massage our data. Well, here we have this thing called scikit-learn or sklearn, right? This is the model building library. Lib for short, right? So remember when we imported Pandas, import Pandas, and we said as PD, all right? So when we imported Pandas, we imported the entire library, entire lib. Well, that's okay, and we can do that, but that's not the Pythonic way. So what is the Pythonic way then? The Pythonic way is to only import, down here you can see this is what we're doing, what we need from what? From our libraries, sklearn. Sklearn is scikit-learn. All right. Import. Here's our import. We're doing the import thing the same as we imported Pandas here, right? Import what? We're only importing these items, these objects. We're importing data sets and metrics because this is all we need, right? This is the Pythonic way to do things, okay? So going forward, when you see the from at the beginning before an import and the library, it means it's only importing a section or an object from the library to do the job. Only what it needs. Okay. All right, in this lesson, let's walk through an end-to-end model build. The great part about Python and scikit-learn is that in about 12 to 15 lines of code, we can create a model end-to-end that brings in the data set and then makes a prediction. In the next lesson, we'll walk through every line of code. But right now, let's go ahead and just knock out a model end-to-end. So we need from what? This is what we've seen in the previous lesson. Import data sets. So import data sets. Scikit-learn has some data sets that we'll use for learning, and that's what the data sets is. We can import it and we don't have to import it from a URL or bring it in from a CSV. It's baked into scikit-learn, which we get when we installed Python via Continuum Analytics. All right, so SVC is a support vectors classifier. More on that later. And it is called an SVM.svm. All right, so it's a support vectors machine, but everything inside of scikit-learn is called a classifier. All right, all the models are classifiers. So let's remember that. No model name scikit-learns, right? There is not. Control Enter. There we go. Let's add another cell. Let's go ahead and load that data set. So data set equals data sets. Now this is the one that's built in, right? Dot load underscore iris, just a function to load that data set so we can work with it. Let's add another cell. Let's go ahead and create the model, or actually we don't have to create the model. What we're doing is using the pre-built model that's in scikit-learn, right? It's that one we just imported, and it's called an SVC, right? Now we need to fit the model to our data. Right? We need to tell the model, hey, this is our data. Can you act on it? Model dot fit ds data ds target. We tell what the target is. Remember our target variable in earlier discussions in the course. That's what that is. Let's print out the model. All models have some additional information that we can use to tune if we'd like. All right, so here is the SVC, Support Vector Classifier model, right? And here is some additional information about that model. Again, not for this class. We need expected. What's the expected? Equals ds dot target. Right. And what the predicted? What's the predicted? Equals model dot fit the predicted data. Model dot predict the ds data, and then we want to print out the metrics about the model. Metrics tell us how well the model did. And as you can tell, I am not the world's best speller. And there we have it. That's it. So in this code, we imported some things that we want to use from sklearn. We imported our data set because, right, this is a supervised learning model and we need to point data at it. We've created this thing called a support vectors classifier. We fit it to our data. We've printed out some additional information about the model. We did it in expected and predicted to compare, and we printed out the metrics of the model. And as you can see, this thing here, again, we're going to talk about that whole bottom row in the next lecture, but precision is something you're going to see often. How accurate is the model? And it says here on the very bottom, it is 99% accurate in predicting what's inside the iris dataset. And we'll talk again about what it was trying to predict, or actually what it predicted quite accurately according to our model in the next lesson. All right, in this lecture, let's walk through every line of code. So what's the first line say? All of these are doing the same thing. They're importing from scikit-learn, which is our library. They're importing what? Well, they say they're importing data sets. This is where our iris data set is, right? Metrics. We need to measure how well our model did. That's where that is. SVC, Support Vectors Classifier. Recall everything in scikit-learn as a classifier. However, in the real world, we call the model support vector machines. All right. DS, this is simply a variable. It's a var. What are variables? They're just containers. They just hold stuff. That's what he's doing. He's holding our data set so we can use them down here. Datasets.load iris, right? This function is loading what? It's loading the iris from our data set, right? Because here is our data set. Model equals SVC. There it is. We brought it in, so we might as well use it. We're going to use a classifier on our data, all right? Again, variables. These are just containers, container, container, right? model fit, we're telling it that we want it to fit our data. Right? We've defined the model here. That's the definition, right? We'll call that def. Now we're telling it to use the model we brought in and fit it to our data and our target. All right? Remember, that target thing is the thing we're trying to classify, right? The data is our training data. Print the model. Print this. Print a variable. Well, what are we printing about the model? We're printing additional info. So we've got additional info about our model here. We're going to make some predictions. Expected is equal TS target, right? What is the expected output on the target variable from a model? What's the predicted one? Model.predict, right? The data. Up here, TS data, right? That's what it is. We're just calling that variable again. Print the metrics, right? Remember, we brought metrics in up here. Now it's time to use it. And inside the metrics is this classification report where it predicts these two things, the expected and the predicted outcomes of the model. All right? It's great that in so few lines of code that we can build an end-to-end model that classifies data to the tune of 99% accuracy. All right, now there are some caveats with that. That's not a real world number, right? What you get in these models isn't what you get in the real world, right? That's okay. We're learning, and this is a great way to walk through the entire model. So now you get the end-to-end process of building a model in Python using scikit-learn. All right, in this lesson, let's learn about matplotlib. If you are a visual person, and most of us are, to the tune of about 90% of the population, then this is your library. Why? Because it is a library for visualizing our data. So it doesn't even need an introduction. That really is all it is. So when someone says, hey, you know what's matplotlib? It's a library for data visualization. All right, so let's work through an example. So the first thing we're going to do, like we do with anything, is we have to import whatever it is we want to work with. And this is called matplotlib. And we're going to import only what we need. It's called, I think it's called pi. It's called plyplot. We'll find out in a minute. As plt. And we need numpy. Import numpy as np. And we hit Control Enter to run our cells. And we add another cell. Clicking on the X button. Clicking on the, not an X, that's a plus. Let's click on the plus button. Let's go ahead and add some data. So this is just fake data. Equals np dot line space. Let's have some points. Actually, the points will be a straight line across the graph. And to do that, we need a 0, a 10, and a 100. All right. There's my lovely spelling. There we go. Let's add another one. And now let's go ahead and plot it. PLT, right, dot plot. So you can see our alias right here, right, import numpy as np. We use it there, right, to plot our line space. Plot PLT. Now we're using matplotlib. Let's go ahead and plot that out. X label, we need a label, equals linear. It does help if you spell things correctly. I promise that'll help a whole lot. All right, let's go. Let's plot PLT. Again, anytime we're using PLT, what we're doing is simply using the alias for matplotlib in order to use a function or an object within that library. So we're going to use PLT. We want a legend. And now let's go ahead and plot out PLT, the show method, to show our line. There it is. We've created a simple line graph. There's our legend. That was pretty straightforward. There are three kinds of graphs you're going to see the most often in Matplotlib. All right, these are line graphs, linear graphs. You're going to see scatter plot, and let's show that now. So let's go ahead and hit a plus. Let's go ahead and import. Again, we can just grab this up here. Control C, come down here. Control V, we want to import Matplotlib. So after we import that, we're going to need some axes. So let's go X is equal to, and we'll just get a whole bunch of data points. And I won't make you watch me type all those out. I think that'd be a waste of time. So let's go ahead and plot this out. We're going to plot PLT, right? Scatter. Why? Because it's a scatter plot. We're going to do X and Y. Did I capitalize those? X, I don't think I did. Let's go Y. X and Y. And we want to show the plot. PLT dot show. And hopefully we get a scatter plot. Y is not defined. X, Y. Well, sure it is. Y is defined up there. Y. Control Enter. Control Enter again. Apparently it wasn't the right case. So now we have a scatter plot. All right. Again, there's not much to this. All right. So we've created a line plot, a scatter plot, and in the next lesson, we're going to create a histogram. And these will be the three different plots you'll see used most often. All right, in this lesson, let's walk through creating a histogram. And it's as simple as creating the line and scatter plot. And then we'll have seen the three most used plots in Matplotlib. So let's go ahead and import. Import what? Import NumPy as MP. Import PyLab as PL. Let's do some dataset equals mp.random.normal. Let's go with that. Let's go with 5.0. Let's go with 3.0. And let's go with the 1000. Let's see, PyLab. That doesn't look like Matplotlib. Actually, it is. So let's come up here. A little bit of pound sign for a comment. So PyLab is a module. Most say it is discouraged. This usage is discouraged. I say go ahead and use it. If we're really discouraged, they remove it. All right, let's go to the next line. So let's go ahead and plot PL, plot our hist, H-I-S-T, on our DS, on our data set, right? Remember, just a variable. Now we're using the variable. We've declared it. We might as well use it. Let's go ahead and make the plots. PL.xLabel, X. On our DS. Now we want to show it. Again, it's as easy as show function. You say, wow, that Mike can't spell at all. X L-A-B-E-L. No, Mike cannot. And there we go. There's our label. I'm not sure why it's those funky colors. I didn't specify colors anywhere. Let's hit enter again. There we go. So we have what sort of looks like a, what is going on? Let's go with 1000. I want a normal Gaussian curve. There we go. So that's what this is called. In statistics, this distribution is called a Gaussian distribution. And boy, do data scientists love that word. So you're going to hear that a lot. What it is, it's simply this distribution, which means that in this range, right, there's only a small group. As we move out, people are included in a bigger group, and then from somewhere here and somewhere here, 99% are included. All right, that's all a normal Gaussian distribution curve is. All right, so we can see how easy it is. Again, with just what 1, 2, 3, 4, 5, 6 lines of code, we can turn a data set into a histogram. And that's all there is to creating a histogram in Matplotlib. All right, in this lesson, let's talk about what NLP is. NLP stands for Natural Language Processing. And here is the best definition I could find. All right, so the idea of natural language processing is to do some form of analysis or processing where the machine, or the computer, can understand, at least at some level, what text means, what it says or implies. All right, so how do we do that? How do we get from these words, right, these are words, to numbers? Well, what we do is to break things down into their smallest form. So here's an example. In this section, we're working with this, NLTK, and this is a natural language toolkit, right? And it's a toolkit for NLP, for natural language processing. Here, we've seen this before. From what? From NLTK, import what? Word tokenizer. Right? Remember what tokenize means? It means to break things down into smaller pieces. All right? Word tokenize. Right? We've brought it in. Let's go ahead and use it. Word tokenize this sentence. And what it's done is broken this sentence down into words, even the period. Right? So this is the token. We'll call it toke. That's a token. And all these are tokens. All right. So once we break these down into tokens, we continue to step through the process. We look at words like eyes. I is what's called a stop word. Stop words have no meaning, and we can get rid of them. What about the word like? Like we need. That definitely has sentiment. Mics, courses. All right, we're keeping all this. We can get rid of that too. So now we have 3 words. These are 3 tokens. So now what do we do? Well, oftentimes, learning from text, we have this thing called a bag of words. And what we do is we create a dictionary of those words, and then we count their frequency. This is a bad example. I like Mike's courses. Mike shows us each line of code. Right. And what we would do is first kill the stop words, right? And then count the frequency of the words that are left. Mike. There's Mike once. There's Mike twice. Mike occurs in this body of text twice. How about shows? Shows occurs once. Code is once. So again, not the world's best example. How about like? Shows us like appears once. So what we do now is we count the number of words in a body of text, right? Let's say this is a tweet about a movie. Well, if there are a ton of likes and loves, then that's going to be a positive tweet. What if there are a bunch of hates and sucks? Right? That is going to be a negative tweet. It seems rather simplistic, but this is actually how sentiment analysis is done. Well, it's one way sentiment analysis is done. So this should give you a basic idea of how we break down words or text into numbers and make sense of those numbers. All right, in this lecture, let's talk about what tokenization is. Tokenization is very easy to define and understand. It's more difficult to implement. So it's the process of breaking up a piece of text, now that's the key word, into many pieces. Down here, you'll see this is actually an example of tokenizing a paragraph because we have two sentences. We can actually also tokenize a sentence into its distinct words. All right. So tokenization is not specific to words or sentences or paragraphs. It's really just the process of breaking up text into different structures. All right. Let's talk about the code. So from what? Anytime we see this, we know we're bringing in only a piece of the library from this thing that we're going to talk about throughout the course, from this library. This is our library, and it's called NLTK, right? Tokenize, we're going to bring in this thing called tokenize. Import what? Import sent tokenize. Well, what's that? It's just short for sentence. So actually it really should be, instead of sentence, this really should be para for paragraph, right? Because what we're really doing here is separating a paragraph into disparate sentences. All right, so all we do is create this thing here called a variable. And all a variable is an empty container for our paragraph here. That's all it is. So we're going to use sent tokenize, right? This thing we brought in up here, this object from NLTK to tokenize what? To tokenize the sentence. Actually, what we did, let's change it. We didn't tokenize the sentence, we changed it to a paragraph because we've got a paragraph. So para, right, to tokenize that paragraph. And it did that. When we hit Control Enter, we put our cursor in the cell here, and we hit Control Enter, it did exactly what we asked it to. It tokenized our paragraph into two sentences. Right? That is the very basics of tokenization, and it's what we're going to be talking about in an in-depth fashion in this course. All right, in this lesson, let's go ahead and tokenize some text. Recall from our earlier lesson what tokenization is. It's breaking up text into smaller pieces. So let's go ahead and do that. So we're going to do a from because we're going to import NLTK. That's the library we're talking about in this section. And that is a library, kind of the de facto one for natural language processing. Tokenize. Let's go to import. Let's spell it right. Sent tokenize. Sent tokenize is sentence tokenizer. All right, so we're going to break up a paragraph into sentences. We'll call this para for paragraph equals thanks for taking my courses. You guys rock. Learning is fun. Please take the rest of my courses. All right. Enter. So now what? Well, now we have to do something to that para we just declared, right? That para is a variable, right? It's just a holder for the paragraph. So we brought in sent tokenize, so let's go ahead and use it. Tokenize what? Para. So let's hope this counts. There we go. So what it did was just break our paragraph into sentences, right? Let's go ahead and do something similar. Control copy. Let's add a cell, plus button, that I keep wanting to call an X button. And now instead of sent tokenizer, let's import word tokenizer. What do you think that's going to do? Yes, sometimes it's pretty straightforward, isn't it? Yeah, we're going to tokenize the words, right? So let's go ahead and see paragraph, word tokenize. So we want to associate word tokenized. Word tokenized. What? Para. And now we've tokenized these sentences into words. All right. Now, just for fun, let me show you what stop words dictionary looks like. So remember, we have a whole bunch of words that don't have any meaning. If you look at these, you should be able they should just jump right out. But if not, we have a dictionary for them. All right. And let's go ahead and from NLTK corpus. I do love that word. Import. Remember, a corpus is a body of text. Stop words. And do what? Stop words in English. Yes, there are other languages. Let's take a look at the stop words in English. Let's see. Stop words. What did I do? Stop words. Dot words in English. All right. So we've got a list of stop words in English. And then what we do after we tokenized our sentences here is run this. The next step would be run it through the stop words dictionary. And it would pick out, I and you and is and remove those. So at this juncture, I think you can get an idea of just how powerful the toolkit or the tool NLTK is.